does not.
You're right, it's just a tiny.
What does it do?
Moves it.
Just moves foods. Let me show you a picture before we continue on. There's a difference between making smaller and pushing. They're not the same thing. So this one here, this is your esophagus. I'm simply shoving the food down. So this is the bolus. The food's exactly the same at the beginning and the end. So I haven't done anything to it. I haven't digested it. So that's just shoving food. That's not digestion.
Terrible too.
Okay, so that's just peristalsis. So the esophagus shoves food. It does not do anything to it. So put a big no there. Does your esophagus have enzymes? Say no.
No.
Does not produce any enzymes. Does it absorb anything? No, it does not. All right, it just shoves food. Stomach. Does your stomach physically digest?
Yes.
Yes, it does. That's called the churning. That's actually grinding food. Does it digest chemically?
Yes.
Yes, it's called vomit. All right. Does it absorb anything?
Yes.
Okay, there are two answers. You can say sort of a yes-ish. Is that even English? There are only three things your stomach can absorb. Anyone know what three of them might be?
Alcohol.
Alcohol is one. You're college students, that's all you need, right? Aspirin, some vitamins. That's it. So on a test, if you put yes, it's fine. You just got to tell me that's just a few things. The better answer on a test is no. That's because I learned that doesn't count as food. I mean, yeah, alcohol maybe does. Right? So the stomach can absorb some things, but it's not a major absorptive organ. So the best answer is no. Small intestine. Does the small intestine physically digest?
No.
Yes.
Yes.
I don't know.
Yeah.
It's a yes. Let's prove, well, I can't prove it. Let's prove it. Let me show you what the small intestine does. So it's sort of like an esophagus, but a slightly different mechanism. So here's your esophagus again. I'm shoving food downwards. Here is your small intestine. I'm not shoving food downwards. What am I doing to the food?
Mixing that?
I'm mixing it. They call it segmentation. I'm splitting the food in half and moving it. Because it's now different sizes and shapes, that counts. So I didn't shove it, I mixed it. And that counts as a digestive event. Right, so you wouldn't know by just looking at it. You'd have to understand that's technically a yes. So small intestine is a yes for physical digestion. All right. Does your small intestine chemically digest?
Yes.
Yes, it does. Does your small intestine absorb nutrients? Yes, it does. Put a big smiley there. Star that puppy. All right. That one's a guaranteed yes for absorption. Can anyone tell me why it's the small intestine that absorbs and not the other ones? What makes that one able to absorb and not the others?
Cilia.
Yeah! Let's look at a picture.
Like that?
Little things, yes, I get it. I teach kids, I get this. Okay. Let me show you a picture of your small intestine. Here's a cutaway of your small intestine. So this is your small intestine up here. It has these nice little folds. Look at the end of the folds. What is that thing sticking on top of the fold? It's a finger called a villi. So here's the finger. The finger have fuzzies. So you have folds with fingers with fuzz. So why would you want all these bumps?
Surface area.
Surface area. And if you look inside the bump, what's that red and blue thing?
Capillary.
Capillaries. What do capillaries do?
Absorb.
Absorb and exchange. So food comes down my small intestine, hits these little thin layers of the villi, and go immediately into my bloodstream. Remember last term, the simple columnar? Right? It's a very thin layer. So my small intestine have a really nice system, a lot of surface area with blood close to the food. So that's easy to absorb. All right, so small intestine is the absorptive organ of the digestive system. Let's keep going. Large intestine, colon land. Yes or no? Does it have physical digestion?
No.
No, in fact you can see it there from other class. No, it does not. It pushes poop. Does it chemically digest?
No.
No, pushes poop. Does it absorb?
Yes.
Yes. What does it absorb?
Water.
Says me. Water.
Fat.
Some fats. some electrolytes, some vitamins. So it does absorb water, salt, vitamin K, for example, but it doesn't absorb everything. So small intestine absorbs anything. This one absorbs waters. This one absorbs booze. Right? There's the basic organ. So now we're going to do the pH. So your mouth, in Biology 112, you had to memorize the pH of your mouth. It was?
7.2.
Close, 7.2 to 7.5. So we're going to say it's neutral. Your mouth is a neutral organ. Okay, tell me about your esophagus.
Acidic.
Neutral. Because you should be swallowing what's in your mouth. So it should be neutral. Well, unless you have acid reflux, which is an abnormality, right? Stomach, it is?
Acidic.
Acid. So it has a low pH. pH about a 2. These are about a 7 and a 2. So I'm happy with acid. So now, small intestines, they are?
Neutral.
Neutral. Basic.
They're considered a base, around an 8. That's you have to know that. And your large intestine is a base. Also about an 8. So again, all you have to know is neutral, acid, or base. That's fine. So now we're going to show you an animation of that part of the chart. Of the yeses and nos, and that sort of acid-base thing. Here, that is. Here.
The primary functions of the digestive system are the breakdown of food, called digestion, and absorption of nutrients. Digestion begins in the mouth, where the teeth break food into smaller particles during mastication.
Yes.
Salivary glands, located near the oral cavity, secrete saliva,
Yes.
which begins chemical digestion and keeps the food moist. As food is swallowed,
Notice the food's still there, right? So we didn't absorb it. It's still there. So now we're going to, that's why you got to know for number 3. Yes, yes, no. Now we're going to make it go down your throat.
the soft palate blocks the upper pharynx to prevent food from entering the nasal cavity, and multiple voluntary muscles in the face, neck, and tongue contract, pushing food particles through the pharynx. The food passes over the epiglottis, which prevents food entry into the respiratory system, and then into the esophagus, which connects the pharynx to the stomach. The one-way movement of the food mass, now called a bolus, is controlled by wave-like involuntary muscle contractions.
So this is not digestion. That's why it's all nose. We're just pushing food.
This movement is known as peristalsis. The bolus now enters the stomach. Folds in the stomach wall, called rugae, allow for expansion as the stomach fills. Stomach cells secrete hydrochloric acid, pepsinogen, and various regulatory hormones that chemically digest the bolus.
That's the yes.
Muscular contractions in the stomach churn its contents to further break down the bolus and mix it with stomach secretions to form a thick liquid called chyme. Chyme exits the stomach through the pyloric sphincter and enters the small intestine, the major site of nutrient absorption. The small intestine consists of 3 parts: the duodenum, jejunum, and ileum.
By the way, you can say duodenum. It's okay.
Bile from the liver and digestive enzymes from the pancreas empty into the duodenum to aid in digestion. Absorbed nutrients pass from the lumen of the small intestine into blood and lymph.
So notice it's the first time the person said about absorbed nutrients. The small intestine absorbs the nutrients as well as digestion.
Chyme not absorbed in the small intestine enters the large intestine. As it passes through the cecum and ascending, transverse, descending, and sigmoid colon, water and salts are absorbed and chyme is converted into feces.
So we absorb, but it's mostly water soluble, like salt, electrolytes, some of the vitamins, that kind of stuff.
The rectum stores feces until nervous stimulation initiates the defecation reflex, resulting in elimination through the anal canal.
And they don't show that. So again, the basic yeses and nos. All right, so now comes the harder part, the enzyme end of town. So this will be a big, ugly list, so make sure you have some space. It's going to take up more room than your boxes are going to be. Don't blame me. We have to go through now and do the enzymes in each organ. So what I'm going to do is I'm going to be listing them in here. And I'm going to be also listing them separately by group. So one way you want to study these is not only just where they are, but what foods they digest. Because I could ask you that question too. So I have a carbohydrate enzymes will be here. Enzymes that deal with proteins will be here. And what other foods are there? Fat enzymes will be here. Okay, so we're going to sort them by where they are and what food they digest. Let's start in the mouth. Name an enzyme that I find in the mouth. I heard someone say amylase. Amylase. Okay, so in Biology 112, they're supposed to teach you something. Okay, the suffix ase means enzyme, right? What was that word in front of the ase? What was that? The prefix was? Which is the substrate. What the enzyme digests is the first half of the word. So does anyone know what amylo is?
Starch.
Starch. So amylase digests starch. That's why it's named amylase. So which group would amylase be in? It's a carbohydrate. So amylase digests starch. That's what amyl means in science land. It's an enzyme for digesting starch. Name another enzyme in your mouth. What was it? I heard it. Lipase. Or lipase, you can say either way. So, lipase, let's see, L-I-P-A-S-E. It's going to digest lip, which is?
Lipids.
Lipids are fats. So lipase is going to go way over here. Lipase digests fats. So far so good? Those are the two. So now, source. Someone tell me the source for amylase. Salivary glands. Very good. So let's review how we knew that it was the salivary glands. Look in the book. What word comes in front of amylase? They put, that's always the source. So your book says salivary amylase. That word means the source. So salivary amylase to biology land, enzyme to digest starch coming out of my spit. So salivary amylase. So that tells me it's produced in the salivary gland. So tell me lipase. Where's it made? What's the name in front of lipase? Lingual. Where's your lingua? That's your tongue. So lingua is tongue source for lipase. Those are the sources of the enzyme, lingual lipase. So far so good? We'll finish going. Substrate and product. What's the substrate for amylase? Starch. That's what it digests. Biology 112 review. What does starch become when you digest it?
Glucose.
Sugar. Yay. We'll say sugar for today. That's fine. So starch is the substrate. This is the product. If you don't remember that, sue your 112 teacher. All right? So substrate's what you start with, product's what you end with. So let's do lipase. What would be the substrate for lipase? Fat. And what does fat become when you digest it?
Fatty acid.
Fatty acids. My first class didn't even get that right. I had to yell at them. All right. So those would be the substrates and products for amylase and lipase. Fat to fatty acid, starch to sugar. So far so good? Okay. Give me the enzymes of the esophagus.
None.
How can it be none?
Because it doesn't.
Because it doesn't do anything. So none. So what are the source of the enzymes? None. What substrates are there? None. You hope that's on the quiz, right? Nothing. Doesn't do anything. Just so your stomach's not in your chin. All right, now it leaves the stomach. Are there enzymes? Yes, there are. So let's name some enzymes in the stomach. Pepsin. Okay, pepsin is named differently. It's not an ACE, but it works. Pepsin digests what category of food?
Protein.
Protein. Peptide, remember that from 112? Polypeptide, Pepto-Bismol, peptic ulcer, pepsin. Okay, they all mean protein. So we're going to digest protein. Name another enzyme present in my stomach.
Lipase.
Lipase. Okay, now we need the sources. What's the source for pepsin? Stomach. Because it's pepsin, it comes out of the pep. So lipase, what they call it in the book? They call it, what kind of lipase?
Gastric.
Gastric lipase, which means it's from the stomach again. So those are both sourced from the stomach, gastric lipase and pepsin. Substrates and products, okay. Pepsin, what's the substrate?
Protein.
Protein
Amino acids.
to amino acids. You didn't even wait for me to ask, all right. Biology 112, proteins are broken down to amino acids or oligopeptide. All right. So tell me about lipase. What's the substrate?
Fat.
Same as over here. So it's the same enzyme. The one in your mouth and one in your stomach are exactly the same. They do exactly the same job. The only difference is that's in your mouth, this is in your stomach. It's the same enzyme. Nothing is different. So they repeat. Some of the same enzymes repeat. Okay, now we're going to do the other column. What else is in my stomach besides those two things?
Hydrochloric acid.
Hydrochloric acid. Okay, now we got to figure out why. There are two reasons you have acid in your stomach. Anyone from last term remember one possible reason for acid in your stomach?
Kills parasites.
Kills parasites. The immune barrier. Yay. It kills things. So when you eat a bad hamburger, it doesn't kill you quite as fast. What else is it for besides an immune barrier? And destroying your carpet when you throw up.
Melt your food.
It does melt it. There's something else it's for. It activates the enzyme.
Oh.
So you're reading Saladin, talks about pepsinogen. That's the inactive form. It hits the acid, becomes pepsin, which is the version that works. So it turns on the enzymes and is an immune barrier. That's why it's there. So let's keep going. Small intestine. Give me some enzymes for the small intestine. They won't fit in the box. Give me some.
Pepsin.
No, not small intestine.
Amylase.
I have amylase again. Give me another one.
Trypsin.
Okay, lipase, trypsin. There's a whole bunch, right? So we're actually more than we have room. So I'm going to put them over here. No, I'll put them over here. So here we go. We're going to make a big list of small intestine enzymes that you have to know. So we have amylase, we have lipase, we have trypsin, you have chymotrypsin, you have peptidase, you have maltase, sucrase, lactase, carboxypeptidase, carboxypeptidase, and dextrinase. That's enough. There are more, but that'll work. So here are some of the enzymes that will not fit in your box, but there they are. So we're going to go through each one and put it in the right category. So tell me where amylase digests. It digests what?
Carbohydrates.
It's the same enzyme as here. The only difference is this one was in your mouth, that one's in your small intestine. Lipase, right here, same enzyme. Does the same job. Okay, trypsin and chymotrypsin have the same last name, so they do the same thing, which is Proteins. So put them over here. Trypsin and chymotrypsin. Those are protein digesting enzymes. So they're going to take protein to amino acids. So we can check mark those. Okay, peptidase. Can you take a guess on peptidase and carboxypeptidase?
Protein.
Protein. Pep. So the peptidases are like pepsin. They're all proteins because they deal with peptides. So those are 4 protein enzymes. Now, dextrinase, maltase, sucrase, lactase. Those do what? Carbs. Put them here. So we have dextrinase, sucrase, maltase, lactase. All right, from the names, can you guess what they're digesting?
Dextrin, sucrose,
Maltose.
maltose.
Lactose.
And what are those?
Sugar.
Those are sugars. So we're going to take sugars, like disaccharides, make them simple sugar. So those are 112. These are like disaccharides to monosaccharide. So milk, sugar, beer, sugar, table sugar, honey, right? So you're just breaking things down. But those are carbohydrate enzymes. Yes.
So supposedly, are you not really using lactase when you're no longer ingesting milk?
Correct. It's an inducible operant. You only turn it on when you drink milk and turn it off when you don't.
So it's really for small, like babies and small children.
Anyone that drinks milk and is not lactose intolerant. Yeah.
So does it activate it when we drink other animals' milk too?
Yes.
Interesting.
Anything that has milk sugar.
Okay.
The only time it would not be active is if there's no sugar in the milk, like cheese or something. So okay, our enzyme. So thou shalt know that big chart for that box. Now we gotta finish this up because we have to still know the source of each one I listed over there. Let's go through it. For the amylase in your small intestine, what's the source? Pancreas. Because it says pancreatic amylase. So you have an amylase from saliva, and an amylase from your pancreas. They're the same enzyme, different source. Okay, lipase. What's the source for the lipase in the small intestine? Like the same thing. Pancreatic lipase. Pancreas. Your pancreas makes a lipase. Same job as those other ones. Trypsin and chymotrypsin. Can anyone tell me where they're made?
Pancreas.
Say pancreas. That's why I'm pointing at it. So those are pancreatic enzymes. Trypsin and chymotrypsin. Okay, smarties. Peptidase. Where's it made? No, it's not. It's called the no. Femur. Right. It's called. Your book calls it the brush border. From what I taught you earlier, can anyone guess where the fuzzy edge is?
The lining of your small intestine.
Lining of your small intestine. So, when you're reading Saladin, and he talks about brush border enzymes, he means they come from the small intestine themselves. That's the brushy border. Be a drunk Roman looks fuzzy. The fuzzy edge. So some of them are from the pancreas, some are from the small intestine, but they all go in the same organ. They're all in the small intestine organ where they work. So that's a brush border enzyme. So is this one, peptidase, the brush border. The same last names, give them the same location. So now tell me about those enases ones over there. Where do you think they're made? Can you take a guess?
Pancreas.
No.
Liver.
No! Brush border, the small intestinal linings. So in your small intestine, you have enzymes from the pancreas and the small intestine all doing their job inside the small intestine area. Let's go through the substrates and products, which we did, right? Amylase, starch to sugar. These are sugar to more sugar. These are protein to amino acids, fat to fatty acids. So it's the same substrates and products as here. Now we're going to fill in the other column. What other things are going to be in a small intestine besides those? The video showed you 2 of them. Bile. Okay, let's stop there. What is bile for?
Break down fat.
Break down fat, emulsify fat. Blah.
Gallbladder.
Stored in your gallbladder, produced by your liver. We'll do more of that next week. So notice I underlined emulsify. I did not write down digest. From Biology 112, can you tell me the difference between emulsify and digest?
Mix it. Activate the enzymes.
Yeah, so emulsify means to make smaller pieces. It does not actually digest it. So bile is not an enzyme. If you write that on your quiz, you deserve to get it wrong. Bile is not an enzyme. It doesn't digest the food, it simply makes it smaller. There's a difference. And because of that, because it makes fat smaller pieces, it's easier to digest. So tell me what's in your sink, what your kitchen sink has to make fat easier to break apart.
Soap.
That's exactly right. Bile is soap. You add soap to make your dishes easier to clean. Doesn't clean them, that's what my kids are for. That's to help them clean the dishes. Right? So bile is an emulsifier to help the fat break up, not to digest. So let me show you a picture of bile before I get too far here. All right. There's my bile. I lost my bile. There it is. Okay. Okay, so on the screen, there's my triple whopper with cheese, right there. Fat globule, yeah! Bacon. That thing down here, that's the bile. So this is a bile molecule. Bile salt's basically a soap, amphipathic. And look what happened to the whopper with cheese. What's it doing? It's making it smaller bubbles. It didn't make it go away, it's still fat. And what it's doing is making the fat become little droplets that float around, so it's easier to digest. So that's emulsification or saponification. Right? So bile is an emulsifier, not an enzyme. Make sense? I'm going to beat my hand, but 3 of you statistically would probably get that wrong next week. Right? So that's bile. What else is in my small intestine besides bile?
Time.
Well, that's only not all of them. Right? That's not what I'm interested in. Let's do buffer. Buffer. So tell me from Biology 112 what buffers do. Maintains or reduces pH change, so regulates pH. Okay, go look on the chart again. What pH was my stomach?
Acidic.
Acidic. What pH is my small intestine?
Basic.
How do you do that magically?
A buffer.
You need a buffer. The buffer keeps the small intestine from being acidic like the stomach and keeps it basic like it's supposed to be. Right? So there's a buffer and a bile in my small intestine to keep it basic and to break up the fat. So far so good? Okay, let's do our last one, our large intestine. What enzymes are in my large intestine?
None.
Lipase.
None. Why are there none?
Because you don't do any digestion.
Because it doesn't digest. You told me that. So none. So what's the source of these nones? None.
None.
What's the substrating products?
None.
None. Is there anything else in there? Yes. Bacteria live in your large intestine. So even though there's no enzymes, they're bacteria. Tell me what the bacteria do for you.
Break it down.
Break down what? Break it down. That's so 80s. Okay. What do they break down?
Fiber.
Whatever's in there, okay, we'll talk about next week. But why? Why do you want bacteria to break down stuff in your colon? Well, you don't know this. Okay. They're renters, right? They're living in you. You charge them rent, like in Portland. What do you charge them for the right to eat your poop? They have to give you something. What do they give you? They do. What nutrients do they give you? They produce vitamins. You remember your homework question from last term? Antibiotics destroy vitamin K because they kill those guys, right? That's why you become somewhat hemophilic. And what else do they give you besides vitamins? They give you a whole lot of gas as part of their payment plan to you. So they eat your poop and give you gas and vitamins. That's their job.
Like, can they make serotonin or?
They make some of the gut hormones. So serotonin is one of them. We're going to focus mostly on the vitamin part. So that's the magic chart, right? So let's go through now and see this in action. I'm going to show you a very quirky, strange, but entertaining animation of this. I did not write this. This guy has talent. He really does. So we're going to walk through the chart. And this time we get to pick different foods to go through the system. All right? So let's pick one. Okay, so we have beans, ice cream, Mr. Fish, cupcakes, weird apple. Which one you want?
Ice cream.
Ice cream.
Dinner first, then dessert.
Okay, so the ice cream contains starch, protein, fat, water, and some other stuff. So if you think about your chart, some of the organs have enzymes for some of these, some would not. So as it's going through, he'll change what the animation is based upon the food type, right? So in theory, I'm chewing, yes, physical digestion. Here comes my saliva. Hey, there's an enzyme there. Was it digesting? Starch. So that enzyme must be what? Amylase, because there's starch in purchased ice cream. Here comes my slime. Here's my stomach. Hey, that's protein. What enzyme must that be in the stomach to digest protein?
Lipase?
This could be pepsin, right? Small intestine. I have protein enzymes there. I have starch enzymes in my small intestine, right? Oh, who's that? That guy's cool. That's Mr. Bile. He's going to take the fat, make it smaller. Looks so scared. Who's that then?
Fat enzyme.
What's that called? That's lipase. Remember, the bile just breaks it down. It doesn't actually digest it. The lipase is the enzyme. So now we're going to use the lipase to break it down smaller. This is kind of the creepy part. These are the villi. For some reason, this bothers me. This is not anatomically correct. You get the gist. What am I going to do in my large intestine? What's that?
Absorbing water.
Moving water. Right? I absorb water.
The music's really creepy.
It is creepy. It's like
It's
that
like the
70s
dungeon part.
Space Invader kind of stuff. Oh wow, let's zoom in on my anus. All right. So here's the stuff you couldn't digest. So, want to pick a different food?
Fish.
Mr. Fish. Protein, fat, and water. So now I think this is going to change which organs do what, because there's different ingredients, right? So what's my mouth going to do to the fish?
That's true.
It's going to chew it. What enzymes are going to be used on my fish?
Lipase.
He doesn't show the lipase, but there's no starch. So I would not be using the amylase. I'd only be using positive lipase. Stomach. Here comes the pepsin again. There's protein in my fish. So as you're studying for next week's quiz, this is the kind of logic you want to do. If I have this in my food, which organs are doing what? What enzymes are doing what? Does my small intestine digest protein? Sure does. Ah, the bile man again. The creepy little grabber guys. It just seems wrong on so many levels. My colon, absorbing water. electrolytes, water-soluble vitamins, certain hormones, that kind of stuff. If I don't digest it, I just absorb, and then out this guy. Oh wait, he's not anatomically correct. I know. Right. So you can go through this animation and do all those foods and see how they vary by which enzymes are doing what where. That's because you're going to memorize that chart. Make sense? Okay. So now we're going to add a little detail to that. Which is, there we go. Okay. So we're going back through each food type this time.
Digestive enzymes do most of the work in chemical digestion. However, other chemicals are needed in digestion. They are water.
Yeah. Remember biology 112, water hydrolyzes bonds, right? That's the digestion part. Slowest animation.
Bile.
Here comes bile.
Gastric acid,
That's the HCl.
and bicarbonate.
That's the buffer. Where have you seen bicarbonate before? That was last week, right? So when you form carbonic acid, you make a bicarbonate buffer. So you're using the same chemicals in different ways. The respiratory system uses it, so it is your digestive system. But here's my soap, here's my acid for barrier and turning stuff on, and here's the buffer. So I'm going to use those chemicals in addition to the enzymes. All right? So we can go through each one, but we can just skip ahead to, what is it? Not that one, it's this one here. So we're going to absorb some carbs first. So this will take us
In the
through each
mouth,
food.
salivary amylase from the parotid and submandibular salivary glands begins carbohydrate digestion. The amylase converts starch and glycogen into maltose, multitriose, and alpha-dextrins.
But you can just call sugars in this class for today. That's fine with me.
However, only a few starch or glycogen molecules are completely digested before they enter the small intestine.
I wonder why that is.
This is because the acidic pH of the stomach destroys salivary amylase, and the enzymatic content of saliva is low.
Can someone tell me from Biology 112 why that is? Why does the stomach pH make amylase not work? Start with a D.
Enzymes have particular conditions that they want.
Conditions, and that causes denaturement when you don't, right? So when you add acid, the enzyme denatures and no longer fits the active site. So the idea is my amylase only works in my mouth, it doesn't work in my stomach. Why? There's no amylase there. Right? It's there, but it doesn't work. Right? Click on the small intestine. I will do that.
The pancreas also secretes amylase into the duodenum. In the small intestine, bicarbonate ions from pancreatic juice neutralize gastric acid.
Remember, that goes back to base.
This allows the amylase to continue the breakdown of starches and glycogen into maltose, multitriose, and alpha-dextrins. Amylase acts on both glycogen and starches, but not on cellulose, an indigestible plant fiber.
Click on the small intestine.
Carbohydrate digestion of monosaccharides concludes in microvilli of the small intestine. 4 brush border enzymes are involved. Alpha-dextrinase breaks down alpha-dextrins by clipping off one glucose unit at a time. Sucrase breaks sucrose into molecules of glucose and fructose.
And I don't care if you know the specific ones it makes. That's not the point of this exercise. Right?
Maltase breaks maltose and maltotriose into 2 or 3 molecules of glucose, respectively.
It's important that you realize these are brush border enzymes. These are on the villi.
Lactase breaks lactose into molecules of glucose and galactose. Carbohydrate digestion ultimately produces glucose, fructose, and galactose as end products.
These are simple sugars, monosaccharides that you learned in 112. Now, we're going to look how they're absorbed. I digest them.
All
I absorb
end
them.
products of carbohydrate
Back
digestion
in my small
are
intestine.
absorbed as monosaccharides. Absorption of nutrients ultimately takes place in the capillaries of the villi.
That's why you start the small intestine for yes for absorption. And we use the villi, absorb them. Let's watch this. Click on the brush border.
Fructose, a monosaccharide found in fruits, is absorbed by facilitated diffusion.
Ooh, goes from 112, isn't it? What does that mean, facilitated diffusion?
Gives us a
Goes from where to where?
Gives us a protein across the membrane.
It's a protein across the membrane, and it goes from where to where? Diffusion means it goes from
Low to
high
high.
to low. So there's more sugar in my food, there's less in me, so the sugar goes from food to me, right? That's good old diffusion. So if you watch this, it's going to go through my
Diffusion first takes
brush
place
border into
between
my
the
blood.
lumen and the epithelial cells of villi. Monosaccharides in an epithelial cell then diffuse through the cell's basolateral surface into the interstitial fluid.
In English,
The
it's this way.
monosaccharide eventually diffuses into the bloodstream. The process does not require ATP.
So the trick is it's going right out of my food directly into the bloodstream, now to me. If you don't believe that, give your kid a candy bar, start your watch, 20 minutes later they're bouncing off the walls because of that. Right? It went immediately in their bloodstream, once hit the small intestine, and now they're getting a sugar high. Right? I can prove that with my kids. So that's the absorption of the carbs. So you digest it in the mouth, small intestine, absorb it in the small intestine. Let's do proteins. Just this one here. Okay.
In the stomach, proteins are initially met by hydrochloric acid and pepsinogen, an inactive form of pepsin. The pH-lowering effects of hydrochloric acid convert pepsinogen to pepsin. Pepsin molecules, in turn, act to catalyze the production of even more pepsin. The catalytic action of pepsin breaks proteins into fragments called peptides.
Remember the amino acid chain from 112? Yeah, okay. Click on a peptide. All right, I'll do that.
Protein digestion continues in the duodenum of the small intestine. As chyme enters the duodenum, it is acted on by a digestive mixture called pancreatic juice. Pancreatic juice contains the protein-digesting enzymes trypsin, chymotrypsin, elastase, and carboxypeptidase.
And we're not going to worry about the
Each
elastase.
enzyme effectively breaks a particular peptide bond to produce smaller peptides or amino acids. Trypsin, chymotrypsin, and elastase work to catalyze the breakdown of larger peptides into smaller ones. Carboxypeptidase breaks the peptide bond that attaches the terminal amino acid to the carboxyl end of the peptide.
You'll see there's another carboxypeptidase coming up, so there's more than one of those beasts. Click on the small peptide.
Protein digestion is completed in the brush border cells of the villi. Two brush border enzymes are involved, aminopeptidase and dipeptidase. Aminopeptidase catalyzes the breakdown of peptide bonds that attach the terminal amino acid to the amino end of the peptide. Dipeptidase breaks the peptide bond that holds two amino acids together. The digestion of proteins produces amino acids, dipeptides, and tripeptides.
All right, so now we're going to absorb it.
The end products of protein digestion, amino acids, dipeptides, and tripeptides, are absorbed by the villi of the small intestine. Proteins are absorbed into the bloodstream via three mechanisms: active transport, and both sodium-dependent and hydrogen-dependent secondary active transport. Most proteins are absorbed as amino acids via active transport processes in the duodenum and jejunum. Amino acids may also enter epithelial cells via sodium-dependent secondary active transport.
And I don't care.
Dipeptides and tripeptides are symported with hydrogen ions. Once inside the epithelial cells, the peptide compounds are hydrolyzed to single amino acids. In the final stage of absorption, amino acids move from the epithelial cells across the basolateral membrane, through the interstitial fluid, and into the capillaries via diffusion.
Okay, so I'm still diffusing from here into my blood. There's a little mechanism there. You don't have to know that. So the trick is I'm still diffusing into my bloodstream, in my villi, and my small intestine. So far, carbs and protein are exactly the same. You digest them and absorb them. Here's now a difference. Lipids are a very different beast because of them being lipids.
Lingual lipase, secreted by glands in the tongue, and gastric lipase, secreted by gastric chief cells, hydrolyze a very small amount of triglycerides into fatty acids and monoglycerides.
Okay, so there's my other two. Click on the small intestine. Bingo. One more.
As chyme enters the duodenum from the stomach, it is met by bile salts and pancreatic juice. Bile salts cling to the mono, di, and triglycerides of fat globules. This causes the fat globules to break up into triglyceride emulsion droplets. Pancreatic juice contains large amounts of pancreatic lipase, the principal triglyceride digesting enzyme. Pancreatic lipase molecules attach to triglyceride molecules of the emulsion droplets. Each triglyceride molecule is catalyzed and broken into one monoglyceride and two fatty acids.
Now we're going to
The
absorb.
adequate absorption of lipids into epithelial cells of villi requires bile salts.
Okay, so now you're going to start seeing the differences in here.
Bile salts form tiny spheres called micelles, which work to ferry fatty acids and monoglycerides to the apical surface of the epithelial cells. Free fatty acids, monoglycerides, and some phospholipids and cholesterol molecules diffuse freely into epithelial cells. Meanwhile, micelles diffuse back into the chyme, where they continue their ferrying action. Within the epithelial cells, many monoglycerides are further hydrolyzed by lipase. The result is glycerol and fatty acids. The broken down and absorbed end products then recombine to form triglycerides, which aggregate with phospholipids and cholesterol. The resulting mass, called a chylomicron, becomes coated with proteins and leaves the epithelial cell via exocytosis.
That's a difference. Let's put that on the board. That's a big to-do difference. So what are fats? Watch your eyes, wake up. Ooh. Fat absorption. So absorption, so it goes from the brush border How's it getting out of my brush border toward my blood? By the chylomicrons. So the chylomicrons are what carry the fats away from my brush border. So why do I need to carry the fat? Why do I need these things to get the fat to move? The other ones didn't need it. Hydrophobic. Very good. Remember biology 1 and 12, fats don't like water. So I can't get them to move on their own, I have to carry them. So your chylomicrons are the substances that are going to carry the fats to get them where they're supposed to go. So they're going to be in my brush border, and I'm going to release them by exocytosis, like here. I'm going to take them somewhere. So one of the differences, you need a carrier for fat, you don't need it for the other ones. But we're not done yet, because of watch. There's
Because
another
of their
difference.
bulk, chylomicrons do not enter blood capillaries directly. Instead, they enter lacteals.
Bingo. So they go from the brush border to the chylomicrons to where? To a lacteal. Can someone in English tell me what a lacteal is? It's green.
The capillary of a lymph.
It's a capillary of a lymph, which is your lymph system. So unlike the others, it doesn't go to your blood yet. It goes to your lymph system. So it has a carrier, one difference. Goes to your lymph, second difference. Let's keep watching. From the last term, where does your lymph go eventually?
What?
Eventually goes to your heart via your subclavians. Watch that.
Travel through lymphatic vessels and enter the bloodstream at the left subclavian vein.
How about that? So it goes from your chylomicrons to the lacteals to the subclavian vein. So the other two just go right in the blood in the small intestine. This one takes a detour up your lymph system until it hits your bloodstream. So the fats are not actually absorbed in the small intestine to the blood, they're absorbed to the lymph, and the lymph then carries them to the blood. So you have a carrier and a different route. Make sense? So carbs and protein are the same, fats are the oddball. And next week when we do cholesterol, we'll talk more about this interplay. There they are.
Chylomicrons do not remain in the bloodstream long. They are broken down by lipoprotein lipase in capillary endothelial cells in the liver and adipose tissue.
Make sense? So absorption occurs in the small intestine, just different routes depending on what you're absorbing. Question on the magic chart? Not at all. You're getting tired. Fine. So let's find our last thing to do tonight, which is actually the next page in your packet of pain. Got one more thing to learn, which is this one here. Find page 13. We'll do this together. That's good. All right, got this guy. Complains of heartburn after he eats, belches a bunch, hurts when he lies down. Number one, what's wrong with him? Acid reflux is a good answer. But doctors don't bill for that anymore. What do they call it now? 4 letters begins with G.
GERD.
GERD, gastroesophageal reflux disease, for an extra $250. Right? So these are all the same thing, but this is acid reflux. What does acid reflux mean?
It's going out the way it should.
Acid up. Up what? The esophagus. So we used to call it heartburn in the dark ages, but acid is coming up my esophagus. Where's the acid coming from?
Stomach.
My stomach. Remember, our stomach is acidic. My esophagus is neutral. The acid now goes up my esophagus and begins to burn holes in me. That's what's happening. So, number 2, what keeps that from happening all the other time? Say it loud, what is it? Sphincter! So sphincters are what affect this. So, what are sphincters? Besides me.
Muscles that keep closed.
Very good. So, a sphincter is a valve. Remind me from the heart what valves do.
Close and open.
Close and open, control backflow, right? So you don't want food going the wrong way, so you have sphincters or valves that operate that. So you have to memorize all the sphincters of the GI tract. We're going to list them in order, thou shalt know. We're going to make a sphincter list.
Yeah, a piece of paper.
Besides me. We're just going to do the ones that the food would pass through, not the regulatory ones. So we're going to list them in order. Number 1, called the upper esophageal sphincter. Can someone tell me where you think that is?
Top of the esophagus.
Top of the esophagus. Hence the word upper esophageal. It's at the top of the esophagus. I'm going to show you a picture of that. You look where the arrows are. Here's my mouth, here's my esophagus. Right there, that's my upper esophageal sphincter. Or you can call it a valve, but actually it's a sphincter. And so here it's closed. Here it's opening or relaxed. And here it's closed again. So that's my upper esophageal. It's between two things. What's it between? It's between the what and the what? Make it too hard. Between your mouth and your esophagus. So it's right here. It's between the mouth and the esophagus. It's the top of your esophagus, between the mouth and the esophagus, between those two organs. Your upper esophageal. Okay, so if there's an upper esophageal, can you guess what my next one's going to be? A lower esophageal. Can you guess where it is, see?
The bottom of the esophagus.
The bottom of the esophagus. So what organs is it between if it's the bottom of the esophagus? Between my what and what? Very good. It's between my esophagus and my stomach. At the bottom of my esophagus, between my esophagus and my stomach. So I'm going to show you a picture of my lower esophageal. You look at that and say, well, gee, there's no lower esophageal on there. Yes, there is. Right here. They call it something different. They call it a gastroesophageal. They're the same thing. So if you read along, you'll hear people call it the gastroesophageal, the lower esophageal, the LES. The old word was the cardiac. They're all the same place, right here, between my esophagus and my stomach. So here it's closed. Now it's open. Okay? So that's my lower esophageal or gastroesophageal. So which one comes next, you think? What would be the next organ? I mean, the next sphincter. Goes to the P. You mentioned the inhalation. That one, pyloric. The pyloric sphincter is the next one. And that's where? Where is that? Very good. It's at the bottom of the stomach. We're distal in the stomach. That's between my stomach and my small intestine. So if you're catching on, there's a sphincter between every organ. Just like in your heart, there's a chamber and a valve. Organ, valve, organ, valve. So we use the same logic. So I have a pyloric sphincter between my stomach and my small intestine. Between my stomach and small intestine. So, where do you think the next one should be for following this pattern through?
Between small and large.
Between the small and large intestine. So on this picture, the small intestine would be right here. Can you find the sphincter that would be between the two? Very good. Ileocecal. Formally it's a valve because it's not a circle, but we'll call it a sphincter. It's formally not. So where's that at? It's at the bottom of the small intestine, or the distal end of the small intestine. So that's going to be between my what and my what? My small intestine and my large intestine. Between the two intestines. Okay, 2 more to go. Can someone find them? Look at the bottom center of the screen.
External anus.
We have an anal sphincter. So one of them is the external anal sphincter. And if there's an external anal, guess what the next one is?
Internal.
The internal. They're in the same location. One's inside or deep. The other one is superficial, which is the external. That's at the bottom of your large intestine. So that would be between your large intestine and the toilet. All right? So those are the sphincters thou shalt know. Okay? So here's my question. Why does your anus get 2 and everyone else gets 1?
Because it's got to keep everything in.
It does, but you could do that with 1. Why do you need 2?
In case of emergencies.
Nope. Nope.
Keep out that
Nope.
weird evolution.
Nope. I'll give you a hint. One of those is made out of smooth muscle. One is made out of voluntary muscle. Can you guess why we need that? So, Smooth muscle is the internal anal sphincter. So smooth muscle is what kind of control?
Involuntary.
It's involuntary. Involuntary. So skeletal muscle or voluntary muscle is what?
Voluntary.
Voluntary. The external is voluntary, and the internal is not. So you have a voluntary sphincter as well as an involuntary sphincter. Why? So why does that help? Why would you need a voluntary sphincter?
Go to the bathroom.
So you don't poop on somebody, right? So then why do you need the involuntary sphincter then if you got this one?
Sleeping.
So you don't blow up, right? So the idea is, this is a reflex. The spinal cord's in control of this one. So if you have too much poop, it says go. Your brain says, I don't want to go in my pants, so I'm going to hold it in. When you have a baby, they don't have voluntary control, so they poop whenever there's something in there. You learn to stop the poop by doing that top number 5. But you need 2, so you have control of one and a pressure relief system of the other one. So you can't hold it forever. You can try. Remember last time we did the spinal damage, right? If you damage your spine, you poop your pants because you can't tell number 5 to not poop, to use big words. Okay? Make sense? The other ones are all involuntary. Right? You don't have any control over them, so you need 1. But these are the sphincters thou shalt know. To go back to our case study. Go back to question number, was it 2? 3. 2. Which sphincter do you think it is that would help him keep the acid from coming up? The lower esophageal sphincter, abbreviated LES. You know doctors talking about your LES? They mean the lower esophageal. The one between your stomach and your esophagus. That's the one that's leaking. So stuff, whatever's in my stomach comes up. So, why is it worse after a meal? More acid. Why is there more acid after a meal, say ye? So you can digest. Remember our chart. The other was acid to activate the enzymes. If you eat more, you need more acid to activate more enzyme. So more acid after you eat. What might be another reason it's worse after a meal? What is it? Yes. Fuller stomach. Let me show you a picture of that. Be sure I'm not making this up much. All right? Let me show you a stomach. It's right here. So here's my stomach. So my stomach's about 3/4 way full. So what happened if I ate way too much and I filled it all the way to here? What's right there? That's the sphincter that's leaking. So the fuller my stomach gets, the closer to the sphincter the food is getting. And when you're churning all that, the acid will then splash up toward the sphincter. So the more meal you eat, the more acid in here, the closer to there. Right? So the fuller, the worse. Make sense? Okay, let's finish this up. So next couple questions. Number 4, you're monitoring the pH of the esophagus. How would I prove it's gastric reflux? What's the pH of the esophagus? Neutral. So normally it's neutral. Normal is neutral. If I splash stomach acid up, what would happen?
More acidic.
More acidic. Or the pH would go down, right? Because the acid is leaving my stomach, going into a neutral environment, making it more acidic. Make sense? Okay. We're going to do the next 2 questions next week, so hold off on those. We're going to jump right to number 7. So, what should this person avoid eating before we give them what should eat? What should you avoid?
Lemonade.
Spicy.
Besides those, yes, lemon heads, spices. Which type of food would be problematic? Acidic food would be bad, plus what other kind of food?
Really fatty foods?
Fatty foods and, what's the B?
Protein.
Protein. Why those 2?
Because they take
More.
Let's look at our stomach. What does my stomach digest? Digest what? In your chart? Fats and proteins. So if I eat fats and proteins, I need more acid to make more enzyme active, which means I'm going to digest more in my stomach, right? So I can't give you things that are going to make your stomach have to do more work. We used to call this the steak and egg effect. If all you eat steak and eggs with clients, you end up with this. So what should you eat? What do they give them at the hospital when they have this?
Carbs.
Yeah, the BRAT diet. What's BRAT stand for?
Bananas.
Yeah, rice. Boring food, right? Bland and boring, because you want carbs because they don't get digested in the stomach, so there's no acid problem. Right? Porridge. So bland and boring is better than steak and eggs. Make sense? So for next week's quiz, you need to memorize that big ugly chart and know the sphincters. That is what your quiz will be over next week. I also need your groups by next week, or at next week as well.